So let's talk about oogenesis. So it's a monthly event that makes a single haploid in most females. A haploid is going to be half the genetic information, which is just an egg. Some women will produce two. There's ways that you can give a ton of information, a ton of hormones, and you can tweak this, but we'll talk about that soon. There's going to be embryonic development, which is going to be our germ cells. And what they do is germ cells are going to differentiate into our half genetic material. So it goes from our normal complement of 46 chromosomes to our 23 chromosomes. And as meiosis starts, we can kind of keep going and splitting that in half. And it's said that by puberty, this is going to happen 40,000 times from puberty to basically the time you can't do this anymore. We're starting not to 100% believe that because that was sort of central dogma thinking. We're starting to think that women can produce egg their whole life, that they're able to. And we used to, back in the day, we'd think that you came in with a cache of eggs, and once those eggs ran out, tough. But now we're seeing that females could produce eggs more and more. And we think that there's some chemicals that can help stimulate that. So that's still sort of an area we're still learning about. FSH, which is follicle-stimulating hormone, stimulates the completion of meiosis 1. So we go from our normal complement to our half genetic material, and then we're going to go ahead and start to divide that even more, and eventually it's a little different. So here's the ovary. We have FSH that's going to go ahead and tell us to divide our genetic material in half, and that's going to be done by FSH. One of the splits are going to develop into an egg. The other one sort of just gets absorbed back into the ovary and destroyed. This one will get bigger, it'll become a nutrient, it'll go ahead and start to develop. So if the egg and sperm do come together, they'll become a zygote. If there is no fertilization, this egg will eventually just kind of leave through the menstruation cycle. If we look to see how this process is started in females, we'll see that females will go ahead and start to make gonadotrophin hormones, and that's going to happen from the hypothalamus, and that's going to tell the anterior pituitary gland to make FSH and LH. FSH is going to go ahead and start to make a follicle, and this is going to eventually become our egg. It's also going to lead us to make estrogen, and estrogen is going to start to stimulate LH production. Luteinizing hormone, which is LH, is also going to help make that follicle, and it's going to start to make that corpus lumen, which is going to be the area that the egg will grow in. It'll start to make progesterone and some estrogen, and that's going to increase the ovulation and start the ovulation process. So here's the big picture. The hypothalamus is going to start to make that gonadotrophin hormone, and it's going to tell the pituitary gland to make FSH and LH. The FSH and LH will go to the ovary, and that's going to go to the uterus, and go to the ovary. The ovary will make estrogen and progesterone, and that's going to help build the uterus wall and things like that. The FSH and LH will also then go ahead and tell the ovary to produce estrogen and progesterone, which is going to float through the bloodstream to go to the pituitary gland of the hypothalamus to say, hey, positive feedback is happening, negative feedback is happening, and to stop making gonadotrophin hormone. So we're doing what you told us to do. In our next video, we'll talk about, let's do it now. In males, it works very similar in a way. We're going to have the gonadotrophin hormones stimulating FSH and LH. FSH is going to stimulate those Sertoli cells, and they're going to make these things called androgen binding proteins, and that's going to stimulate the production of LH and FSH. The Sertoli cells are going to stimulate sperm production. LH is going to make these intercostal cells, which is going to start to make testosterone. And that testosterone will now float up to the hypothalamus to say, hey, we're doing what you told us to do. Stop telling us to do this. So how it works is in males, hypothalamus, gonadotrophin hormone. Gonadotrophin hormone is going to go to the pituitary gland to produce FSH and LH. So far, everything in males and females are very similar until we go to the site of origin. Here, we're going to go to the testes, not the ovaries. And it's going to tell the testes to make testosterone. Testosterone is going to float to the pituitary and hypothalamus and all the body parts that need it and say, hey, we're making it, stop making gonadotropin hormone.